do 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 do. And welcome to our video on gravimetric stoichiometry. So that's a mouthful, isn't it? So let's break that down just for a quick second. So gravimetric, you look at the first part here, we're talking about gravity. And so you'll see I put in brackets, this is mass. When we talk about gravity, we're generally talking about mass. And stoichiometry, which is talking about quantities of our chemicals. So when you put those together, we're talking specifically about masses of chemicals. So when we look at gravimetric stoichiometry questions, we are going to follow basically the same 5-step process every time. So I highly suggest you cut this out or you keep it handy and you refer to it over and over and over again. So the 5 steps here, number 1 is correctly balance the equation. So important. If you don't correctly balance the equation, you're going to make some mistakes later on. So first of all, correctly balance the equation. Number 2 is convert the given amount into moles. So far, the only way we know how to do that is by using this formula, N equals little m over big M. Number of moles equals mass divided by molar mass. So we can convert to moles. Then you're going to set up mole ratios, which was talked about in the notes that you guys read through prior to this. Number 4, use mole ratios to calculate the moles of desired chemical. And then number 5, convert moles back into the final unit. So usually we're talking about a mass at this point. So these 5 steps: balance the equation, convert to moles, use mole ratios, or set up the mole ratios, use the mole ratio to figure out how many moles of the chemical that you're interested in, and then convert that back into mass. So here is just a quick little picture of what we're doing. We're taking the grams of unknown, we're using the molar mass, the grams of known, we're using the molar mass of the known to turn it into moles. So this is, again, just using N equals M over big M. Then we use our mole ratio to go from our moles of our known to our moles of our unknown. And then we use the molar mass of the product to turn it back into grams. And when we use that, it's just this rearranged for little m. So rearranged for little m is N times big M. So same 5 steps over and over again. So let's take a look at actually implementing those. So an example here, 6.50 grams of aluminum reacts with an excess of oxygen. Excess of oxygen just means we have lots of oxygen. The aluminum is going to run out before the oxygen. How many grams of aluminum oxide are formed? So we're asked, hey, basically, if we react 6.5 grams of aluminum, how much aluminum oxide do we get? That's what our question is asking us for. So number 1 says to write a balanced chemical equation. So we have aluminum, Al, plus it's reacting with oxygen, an excess of oxygen. Oxygen's diatomic, so it's O2. And you make aluminum oxide, that should be Al2O3. Now we need to balance this, of course, so I could balance the aluminums first, but let's actually look at the oxygen. Here you've got 3, here you've got 2. We know that this coefficient will be a 3, and this will be a 2, and then 2 times 2 gives me 4 aluminum. So there's balanced. All right. I didn't put it in the steps, but what I do like to do is then write down what I know and what I'm looking for. So I'm given some information about aluminum, so I'm just going to write given above aluminum. I'm asked to find how many grams of aluminum oxide, so this is wanted or unknown. So given and unknown here. Now, what I like to do based on that is write down what do I know about them? So do I know M? Do I know N? Do I know big M? Do I know M? Do I know little n? Do I know big M? So mass of aluminum. Yes, we're given that, 6.50 grams. Do I know the number of moles? Not yet. Do I know big M, molar mass? Well, I can look it up. So aluminum, when I look it up, is 26.98 grams per mole. What about aluminum oxide? I'm asked how many grams, so this is actually ultimately what I'm looking for. Do I know how many moles? Not yet. Do I know the molar mass of aluminum oxide? No, but I can calculate it. So it would be 2 times aluminum, which is 26.98, plus 3 times oxygen, which is 16.00, gives me 101.96 grams per mole. All right, I've set everything up. Now I just actually have to go through and do the process. So I wrote my balanced chemical equation. Now let's find moles of our given. That's step number 2. So the way I like to write this out is I write Al, give it a little underline here, and now I know this is what I'm talking about. So I'm going to use my formula, N equals little m divided by big M, 6.50 grams divided by 26.98 grams per mole gives me 0.2409 moles of aluminum. And I don't care about significant digits yet. I don't want to round until the very end. So now I know how many moles of my given. What is step number 3? Set up mole ratios. So our mole ratios, let's see, where's my cursor? Come on. Here we go. So let's set up mole ratio. All right, so I'm looking for, or I know, X moles of aluminum oxide, Al2O3, over the moles of my given, which was the aluminum that we just found, 0.2409 moles of aluminum. When we set up our mole ratio, the other side just comes from the coefficients in the balanced chemical equation. That's why it's important that you balance them. Aluminum's on the top here, so aluminum goes on the top, or sorry, aluminum oxide is on the top here, so aluminum oxide goes on the top over here. So 2 moles of Al2O3. That 2 is coming from right here. Divided by aluminum was on the bottom, so aluminum should go on the bottom, and that's a 4. So 4 moles of aluminum. If we cross multiply, or however you want to simplify to get X here, so we'll end up with, let's see, let's do it over here. 4X equals 2 times 0.2409. Divide by 4, divide by 4, so we have X equals, and if I punch this into my calculator and simplify, I get 0.1205 moles of Al2O3. So I've gone from moles of my given, used a mole ratio to find moles of my unknown, or my wanted. So that's what we did, number 4. Number 5, convert moles back into our final unit. So we want to know, the question asked, how many grams of aluminum oxide, not how many moles. So we need to know how many grams. So again, I'm just going to identify over here that I'm working with aluminum oxide now. And I know my formula, N equals M over M. Going to rearrange that for little m, which gives me N times big M. The number of moles we just calculated was 0.1205, and the molar mass we calculated up above was 101.96. You multiply those two together, you get, what do we get here? 0.1205 times 101.96 gives me 12.28618. And now, because this is our final answer, I'm going to round. I was given, what, 3 significant digits, a 6.50, so we'll round to 3 significant digits, 12.3 grams. And there's our final answer. So if you lay out your work in this logical order, so write out your equation, identify what you know and what you don't know, and then identify what you're doing in each step, similar to this. If you look at the next 2 examples, you'll see it laid out basically the same way. Might be a slightly different spot on the page, but it's laid out all the same way. Go through the same steps. You should be able to get to your final answer. So, good luck.